This is OwlUp, where learning happens in minutes, not hours. For a deeper journey, explore all our courses at owlup.co. Now, let's dive in. Welcome to Chapter 1 of The Universe Explained, A Journey Through Space. In today's episode, titled Our Cosmic Address, Where We Are in the Universe, we'll explore Earth's unique spot within the vast Milky Way galaxy. Get ready to uncover just how small, and yet how special, our cosmic neighborhood really is. Let's dive in. Right now, as you listen, you're racing around the center of our galaxy at roughly 500,000 miles an hour, and yet it feels like you're sitting still. For the next few minutes, let's zoom out, step by step, and figure out where here actually is in the universe. Stand outside on a clear night and pick a star, any star. It feels like a tiny pinprick in a vast black curtain, but that point of light is already part of your location, as real as your street name or apartment number. Astronomers treat the sky the way cartographers treat Earth. They've drawn up coordinate grids, mapped landmarks, and even published all-sky atlases from missions like Gaia and the Sloan Digital Sky Survey. Your true "Where am I" stretches far beyond longitude and latitude. It includes which star you orbit, which neighborhood of stars you share, which larger flow of matter you're drifting along. Like a detailed weather map that shows not just your city's temperature, but the jet streams and pressure systems above it, a cosmic map reveals the hidden motions that quietly carry you through space. Your challenge this week? Learn your full cosmic address, from planet to supercluster. Before we climb the whole ladder of our cosmic address, we need to anchor the first rung, Earth itself. Our planet isn't just a random rock. It sits in a narrow habitable zone where liquid water can exist on the surface. Tilted on its axis and wrapped in a thin, protective atmosphere, Earth traces a nearly circular path around the Sun once every year, while spinning once every 24 hours to give us day and night. Those familiar cycles, sunrises, seasons, climates, are local fingerprints of our position and motion in space, as real as any number in an astronomer's catalog. Move one step up from Earth and you land in our immediate neighborhood, the system ruled by the Sun's gravity. 8 major planets, rings of icy debris, dwarf planets like Pluto, and swarms of comets all share this gravitational well. From far away, astronomers see this region as a flattened disk with a fuzzy edge, where the Sun's pull gradually loses its grip to nearby stars. The outermost comets in the Oort cloud may take millions of years to loop around once. Zoom out again and our quiet Sun starts to look less isolated. It's one of hundreds of billions of stars in the Milky Way, but its local surroundings form a recognizable community. We live in a small stellar suburb called the Orion Arm, a minor spur between larger spiral arms rich with gas, dust, and newborn stars. Nearby bright stars, Vega, Sirius, Betelgeuse, are part of this loose neighborhood. Their changing positions, precisely tracked by missions like Gaia, reveal that even this calm-looking patch of sky is a slow-motion traffic pattern of stars weaving past each other over millions of years. On still larger scales, gravity knits stars into clusters and galaxies into groups. Our Milky Way is locked in a long dance with the Andromeda Galaxy. Both belong to the local group, roughly a few million light-years across. Smaller galaxies, instruments like the Hubble and Subaru telescopes have cataloged dozens, orbit the Big Two the way moons orbit planets. The entire group, in turn, falls toward richer regions of galaxies, especially the Virgo cluster tens of millions of light-years away. Beyond that, maps from surveys like Sloan reveal something unexpected: galaxies arranged in filaments, walls, and vast empty voids. Our local group is part of one of these great rivers of matter, flowing within the Laniakea supercluster. Within this region, gravitational tug-of-war determines which way clusters drift, much like competing pressure systems steer storms on a global weather map. Finally, step out as far as our best observations allow, and you reach the boundary of the observable universe, set not by walls but by time. The farthest light that has had a chance to reach us since the hot, dense beginning of cosmic history. Think about how doctors read a full body scan. They don't just see a vague outline, they tag organs, blood vessels, and even tiny abnormalities, then relate them to each other in 3D. Our cosmic address works the same way. Once astronomers know where we are, they start asking how our cosmic organs interact and what that means for our future. For example, our path around the Milky Way slowly changes which stars pass near us. Over tens of millions of years, that can disturb distant comets and send a few into the inner system, an idea researchers explore when they model past mass extinctions. On grander scales, mapping how our local group falls toward the Virgo cluster lets cosmologists weigh the invisible dark matter shaping those motions. Even the slight offset of our position above the Milky Way's midplane turns out to matter. It gives a cleaner line of sight for studying the crowded central regions, helping refine distance ladders that ultimately set the size and age of the observable cosmos. Knowing our full cosmic address lets us ask sharper questions, not just grander ones. Future maps will trace how matter clumps and stretches, like watching dough rise to reveal hidden air pockets. That reveals where dark matter must lurk, which paths galaxies prefer, and where calm, metal-rich regions might shelter long-lived civilizations. As instruments push deeper, our coordinates could become the baseline for comparing entirely different cosmic neighborhoods, not just cataloging our own. As surveys sharpen our "you are here" dot, we can start asking who else and what else is here. Future maps may flag strange energy beacons, oddly quiet regions, or places where chemistry took different turns, like tasting subtle spices in an enormous stew. Knowing our coordinates is just the prologue. The real story is what we choose to explore next. Here's your challenge this week. Tonight, or your next clear night, go outside and use a stargazing app to actually trace our cosmic address. Locate Earth in the solar system by finding Mars or Jupiter, then zoom out in the app to see the Milky Way and pinpoint roughly where our solar system sits in one of its spiral arms. Take a screenshot at each level: planet, solar system, Milky Way, local group of galaxies, and label them with where you are in that structure. Then, share one of those images with a friend or on social media, and in a single sentence, explain our cosmic address as if you're giving someone directions to your home in the universe. This was OwlUp, your daily step forward. To keep learning with structured courses and more insights, go to owlup.co. Until tomorrow!